Good morning, everyone. My name is Jaekun from Yonsei University, and today I'm pleased to present our research titled "Less is Better: A Comparative Analysis of Guidance Methods for Long Context Window-Based Legal Interpretation." This work was co-authored with Professor Ghang from Yonsei University. Okay, so let's begin by understanding the difference between legal interpretation and legal extractive QA. In extractive QA, answers are explicitly stated in the legal text. For example, if someone asks you what the minimum stair width is for 4,000 square foot office building, the answer is quite straightforward. You might look up relevant provisions in the International Building Code, and you might find one provision that states if the occupant load is less than 50, the required width is 36 inches. You then calculate the occupant load based on another provision and determine it's under 50. So the required stair width will be 36 inches. Now consider a legal interpretation case. Suppose someone already found that under Article 44 of the Korean Building Act, their building site must adjoin a road. Then they might ask, what type of site qualifies as a road? If you check Article 44, this time the answer is not explicitly stated in the text. To answer this type of question, you must reason through multiple provisions and interpret them together. So legal interpretation involves implicit reasoning, cross-referencing, and high degree of contextual understanding, which make it far more complex than just extractive QAs. This is why more than 900,000 civil complaints about building code interpretation are filed annually in South Korea. Traditionally, three methods have been used to utilize large language models, or LLMs, for legal tasks: retrieval-augmented generation, or RAG, fine-tuning, or prompt engineering. RAG is the most common, but has two key limitations. One, it is highly dependent on the database, connected database structure. And two, chunking the data during the database construction often cause context loss, especially in long documents. So our goal is to retrieve legal provisions without building a RAG pipeline or fine-tuning using the long context capabilities of LLMs. To leverage the extended context windows of modern LLMs, we designed 6 different prompt strategies. To emphasize again, we did not use or apply any additional programming techniques like LLM, RAG, or fine-tuning other than prompt engineering. To clarify, the term context windows refers to the maximum number of tokens or individual elements that a model can process at once. Most traditional large language models have limited context windows of about 100 to 200,000 tokens. However, modern long context windows, or LCW models, we call it, can handle significantly larger context, typically exceeding 1 million tokens. This extensive capabilities allows models to analyze and interpret much longer contents without losing their context, making them particularly valuable for legal interpretation. Now I will explain how the 6 prompt variant strategies are constructed. So all prompts share a common structure: basic prompt, high-level community summary, or HLCS, task context, and response format. The basic prompt defines the task without any detailed additional information. HLCS, or high-level community summary, provides a high-level overview of the legal document, which we implemented using provision titles. For task context, we tested 3 types of context. Firstly, basic context retrieves only the most relevant provisions of with the user's inquiry. And secondly, exhaustive context recursively retrieves all reference provisions. For example, it begins with provisions that are directly related to the user's inquiry. And then it follows any references with those provisions to other provisions and repeat this process recursively until it reaches provisions that are no longer relevant to the original user inquiry. Thirdly, structured context follows the legal hierarchy. For example, in Korean legal system, laws are consist of 3 steps: act, decree, and rule. So the model's searching step is limited to the 3-level hierarchy. If the legal system of another country is applied, the searching step of the structured context may be adjusted accordingly. We also designed 2 different response formats. Basic format is a list of tuples containing law name and provision number. The exhaustive format is a dictionary that tracks parent-child relationship of the referencing provisions. This helps us track the reasoning path that the model followed. Using these components, we created 6 prompt variants, 3 without HLCS, called unguided, exhaustive, and structured, and 3 with HLCS added to each of the above. We evaluated the method using 171 official legal interpretation cases published by South Korea's Ministry of Government Legislation. For each case, we first retrieved the relevant provisions using our proposed methods and fed the results of provisions into Gemini 1.5 Pro to generate a response. Finally, GPT-4o assessed the quality of the response by comparing it to the corresponding official answer. Surprisingly, the unguided search without HLCS achieved the highest accuracy of 63.16%. However, adding HLCS led to more consistent performance across all prompt different strategies, reducing accuracy variance. So this indicates that providing a well-structured summary of the document's content may enhance the stability of LLM responses. In multi-hub analysis, models often reference Article 2 of the Korean Building Act and its enforcement rule, which define legal terminologies. So on top of it, HLCS reduced the number of searching hops, especially hops across different legal documents labeled as CDH or cross-document hops on the left side plot. So the results reflects that the performance stability observed when using HLCS attributed to its elimination of unnecessary searching hops. We are actually currently expanding this study to compare our method with RAG-based techniques and state-of-the-art LLM models. Initial results suggest that prompt-based LCW methods, our methods, can outperform RAG and match state-of-the-art models without the need of additional database or fine-tuning. And moreover, applying our method to Claude 3.7, which was the best among the state-of-the-art models, yielded a 10% improvement, confirming that our approach is model agnostic. So to summarize, 1, less guidance to LLMs can yield higher accuracy. 2, HLCS, high-level community summary, improves response stability and search efficiency. And 3, LCW LLMs naturally refer to definition provisions, leading to more reliable legal interpretation. So overall, the LCW approach can overcome key limitations of RAG using prompt-based strategies alone. In the future, we plan to explore more token-efficient strategies and validate our approach on different legal two-way datasets to assess generalizability. This research was supported by Korea Agency for Infrastructure Technology Advancement and the Hans Fischer Senior Fellowship Program at the Technical University of Munich. Yep, thank you very much for your attention, and I will be happy to take any questions.